Hi everyone! Today I'll be presenting activation functions decoded. We'll go over what activation functions do in neural networks, the classic and modern types, and how to choose the right ones for your model. Let's start with the basics. Activation functions give neural networks their power. They introduce nonlinearity, allowing models to learn complex patterns that linear models can't capture. They also decide whether a neuron fires or not, shaping how information flows through the network. Good activation functions share key properties. They should be nonlinear, differentiable for back propagation, and ideally have zero-centered outputs to keep gradient stable and learning efficient. The two classic activation functions are sigmoid and tanh. The sigmoid maps inputs between 0 and 1, but it tends to saturate, meaning that gradients become very small and learning slows down. Tanh improves on this by centering outputs between -1 and 1, but it still suffers from saturation at extremes. Then came the ReLU, or rectified linear unit, the most widely used function today. It outputs 0 for negative values and the input itself for positive ones. ReLU's simplicity and efficiency help drive the deep learning revolution by avoiding the vanishing gradient problem. To overcome ReLU's limitation, the so-called dying ReLU problem, we have improved versions like leaky ReLU and preLU. Leaky ReLU allows a small slope for negative inputs so neurons don't completely die. Prelude or parametric ReLU makes the slope learnable, letting the network tune it during training. Then we have ELU and CELU. ELU outputs small negative values, helping activation stay closer to 0 and speeding up convergence. CELU or scaled ELU goes even further by self-normalizing activations. It keeps output stable across layers without any extra normalization steps. The trade-off is that they're computationally heavier than simple functions like ReLU. Modern deep networks often use Swish and GELU. Swish multiplies the input by its sigmoid value, creating a smooth, flexible curve that outperforms ReLU in very deep networks. GELU, so for Gaussian error linear unit, combines linear and probabilistic behavior. It's now the default activation in transformer models like BERT and GPT. Both Swish and GELU maintain strong gradient flow, which means faster and more stable training. There's also maxout, which takes the maximum of several linear functions, and softmax, which converts outputs into probabilities for multi-class classification. When choosing an activation function, think about three things. First, network depth. ReLU is great for shallow networks, while deeper models perform better with Swish or GELU. Second, data type. If your data includes negative values, leaky ReLU or PReLU are good options. Third, hardware constraints. ELU and CELU improve learning but use more computation, so efficiency matters. To wrap up, activation functions are crucial to a neural network's success. They determine how the model learns, how gradients flow, and how fast it converges. The best approach is to experiment and choose based on your model's depth, data, and performance goals. Thank you for listening.